We're live in person. I'm so excited not to have to be sitting at the desk doing all this stuff. Composite functions. So, all my stuff here. How about we do a color that shows up better? The f of x is equal to 2x squared minus 3. The g of x is equal to x plus 4. And the h of x is equal to negative 5 over x plus 6. Okay, so I think you know how to do all this, but let's just review. How do you find the f of g of 2 or the, the p of the x of 23 or whatever? So you're always going to work inside out. The f of g of x notation is the same as the f, and then it looks like an O, it looks like fog. It is not multiplication. It is not multiplication. It's a composite function. These mean the same thing. So you're always going to work inside out. Let's say I ask you to find the f of the g of negative 4. This is the f of the g of negative 4. Negative 4 plus 4 is 0. And the f of 0, plug in 0, you get negative 3. Excuse me. Excuse me. What about the f of x divided by the g of x? No, let's make that h. I can change my mind so much easier on the board. F of x, 2x squared minus 3 over the h of x, which is negative 5 over x plus 6. You cannot leave it this way. No. Multiply by the reciprocal. So you get 2x squared minus 3 times x plus 6 all over negative 5, which of course is icky math. No negatives in the denominator. Let's look at some common mistakes with I have too much stuff here. Let's look at some common mistakes with squaring. So let's say I ask you to find the f of the g of x. So that is the f of x plus 4. That's the f of x plus 4. So this becomes all of the x's in the f function become x plus 4. So I'm going to take x out and I'm going to put g in. So this becomes 2 x plus 4 squared minus 3. No distributing. You have to FOIL that all out. So this becomes 2 x squared plus 8x plus 16 minus 3. Distribute, combine like terms. 2x squared plus 16x plus 32 minus 3, I believe, is plus 29. Plus 29. Let's worry about the complex fractions. So the mistakes always come in when people try to find the g of the g, or the f of the f, or the h of the h. So let's look at the h function. I gave you a fraction on purpose. Next time I'll be a bit more organized. Okay, so let's look at the h of f. We need to practice using the complex fraction. So the h of f is going to be the h of 2x squared minus 3. X comes out. 2x squared minus 3 goes in. So x is now 2x squared minus 3 plus 6. X went out. 2x squared minus 3 went in. So that's going to be negative 5 over 2x squared plus 3. And of course, the kicker will be the h of h. So this is the h of h, which is negative 5 over x plus 6. This x comes out. Negative 5 over x plus 6 goes in. So this is negative 5 over negative 5 over x plus 6 plus 6. That's a 6. Okay. This is the same thing as 6 over 1. The common denominator is x plus 6. We'll multiply numerator and denominator by x plus 6. Okay, I'm going to leave it in factored form. So in the numerator, I get negative 5x plus 6 over the x plus 6's reduce. We do not cancel, we reduce. The x plus 6's reduce, and you're left with negative 5. So you're distributing. The x plus 6 and the x plus 6 reduces there. And then x plus 6 times 6. I cannot stress to you enough that you do not cross off the x plus 6. Order of operations, distribute, combine like terms. This is so voodoo. No reducing x plus 6 over x plus 6. Distribute. It doesn't matter in the numerator, whatever. You can leave it this way in the numerator, but you do need to distribute and combine like terms in the denominator. I'm just going to leave it. I don't know why, because today I feel like leaving it. Tomorrow I might want to distribute, whatever. Here you get 6x. Plus 36 minus 5 is plus 36 minus 5 is 31. I'm going to do one more. Of course, you can fast forward or do whatever you want. I do want to do another with complex. Okay, so let's look at new functions. Let's say that f is x plus 3 over 2x plus 1. And let's say g is, how about 4 minus x over, how about x minus 8? So I want to practice using the complex fractions. Let's just do f of g, because that's what we're used to. I like using the board so much more because I can just easily erase, and you'll have to let me know if you prefer this or the handwriting. So this is going to be the f of g, 4 minus x, x minus 8. Okay, So in the f function, x comes out. This is now going to be 4 minus x over x minus 8. X comes out, 4 minus x, x minus 8 goes in. The denominator, all the x's get replaced. In the denominator, x comes out, 4 minus x, x minus 8 goes in. So you have 4 minus x, x minus 8, plus, I'm going to put 3 over 1 because you're going to need it in a minute anyway. 2, 4 minus x, x minus 8, plus 1, and I'm going to put it over 1 so it'll help you figure out these common denominators. The common denominator between x minus 8, 1, x minus 8, and 1 is x minus 8. So this whole thing gets multiplied by x minus 8 over x minus 8. That's just 1. It's just a fancy form of 1. Okay, distribute. 4 minus x over x minus 8 times x minus 8. Denominator reduces out, and you're left with 4 minus x. Nothing reduces, so you're left with 3 times the quantity x minus 8. I feel like the chair is in the way. X minus 8 reduces. You're left with 2 times the quantity 4 minus x. Nothing reduces. X minus 8. You cannot reduce 4 minus x. No. Order of operations. Distribute, combine like terms. Then maybe you can factor and reduce, but not right now. Distribute. 3x minus 24. Distribute. This is going to be 2x minus 20. I think. Yeah. This is going to be negative x. 8 minus 8 is 0. Icky. Put it in the numerator. Negative 2x plus 20 over x. 5-1, composite functions.